All right, so hello everyone. We are going to talk about readability. So I don't have an intro slide. I don't usually do intro slides. I'll kind of introduce myself though. My name's Trey. I do Python training, Django training. I do a weekly Python chat online. Let me go back real quick. That is my Twitter handle. It'll be at the last slide as well. Feel free to look me up, and I'm an introvert, so feel free to find me afterwards and approach me if you'd like to talk. All right, so before we talk about readability, let's make sure we are on the same page. Readability is really just the measure of how easy our code is to read. So we care about readability, but why do we care about readability? What makes readability important? Every time you fix a bug, change some functionality in your code, or add a feature to your code, you have to read your code. Code doesn't always completely stagnate. You do need to change code. To change code, you need to read code. Readability is a prerequisite for maintainability. You can't maintain code unless you read code. Also, not all teams are immortal. You do sometimes need to hire new developers. When you hire new developers, you need to onboard them. They need to read code. So it's a lot easier to onboard new developers to your team if your code is easy to read. Okay, before we get into the depths, let's make it clear that what we're not talking about. We are not talking about how easy it is to write code. We are not talking about how easy it is for the computer to run your code. During this talk, we are assuming that source code is primarily designed for human consumption. We're talking specifically about how easy it is for other humans and yourself to read your code. So we'll talk about how to structure your code, which basically boils down to where you put your line breaks and a couple other things. We'll also discuss naming unnamed things and naming things descriptively. And finally, we'll reconsider some of the programming idioms that we use every day. So let's take a look at some small examples. I'll tweet out the slides after this talk. There will be a lot of code examples, so if you miss something, you can look at it later. So let's talk about the structure of our code first. Today, line length is not a technical limitation anymore. Line length is about readability. Long lines are hard to read. Line length is a little flawed, though, because line length is only approximately correlated to readability. When discussing line length, remember that short lines are not the end goal. Readability is the end goal. Maximum line length doesn't matter so much as readability does. Let's take a look at an example. So this code has a line length well under 80 characters. It's about 60 characters in length. As you read this code, you're probably trying to figure out what it does. You won't figure out what this does until you figure out the structure of this code. So this first line, you'll eventually figure out, it has two loops inside of it. It's a generator expression with two loops. That second line is a generator expression with a single loop and a condition. This code is hard to read because the line breaks are inserted completely arbitrarily. The author wrote code until they got to some kind of maximum line length, and they wrapped their lines. The author was valuing maximum line length as important instead of readability. Is this code more readable? This is the same code. This is the same code as before, but we move the line breaks around to split up the logical parts of the code. The line breaks are not inserted arbitrarily here. They're inserted with readability in mind. The human is what matters, not the machine. Let's talk about regular expressions. This function returns true if the string that it was given is a valid UUID, a universally unique identifier. A UUID is a bunch of hexadecimal characters with dashes in between. Is this code readable? So this code is difficult to read because regular expressions are very information dense. Regular expressions are code. They're like mini programs that are written all on one line without any whitespace or comments. Do you write your Python code on one line without whitespace or comments? No. None of us are raising our hands. None of us, you can't even write Python code on one line without whitespaces or comments. Why do we write our regular expressions this way? You might think you have to, and that's a good answer. You don't actually have to, though. When writing regular expressions, if you enable verbose mode, you can insert line breaks into your regular expressions. You can insert whitespace. And in fact, here we've inserted comments as well. Now, the whitespace and comments are helpful. The most helpful thing here, though, is the line breaks. We've broken up this code into logical parts. We went from 2 lines of code there to 13 lines of code. This code is a lot less information dense. So verbose mode allows you to add extra line breaks, which improve readability. If you are using regular expressions, always turn on verbose mode. Regular expressions are code. Let's look at another example. So let's say we are creating a Django model, and one of the model fields has a whole bunch of arguments being passed to it. So we're passing a lot of arguments to this foreign key field, and it's feeling a little unwieldy. Is this a good way to wrap our code over multiple lines? Is this way better or is it worse? What about this one? How does it compare? So would anything change, would our opinion change if we were using all keyword arguments with these functions? So personally, I usually prefer that last strategy when I'm wrapping my function calls over multiple lines. The first one is a little difficult to read, in my opinion, and the second one can get a little unwieldy when we have really long lines like we do here. Would it be better to leave the closing parenthesis on its own line? Like this. What if we added a trailing comma? Would that be better or would it be worse? So personally, I prefer this method when I'm calling a function or constructing a class on its own. Not when I'm defining a function, not in other cases, but when I'm calling a function on its own, I prefer this strategy here when I have a really long line. Now, you may disagree with that, and it is okay for you to disagree with me. Maybe you liked one of those other strategies. The fact that we disagree means that we need a code style guide that documents the way that we wrap our functions in every project you create. You have a code style guide in every project you create, right? Approximately, maybe. This is missing from it though, right? You probably don't talk about the way you wrap your long lines, your function calls, in your code style guide. Consistency lies at the heart of readability. Make sure that you're defining an explicit code style guide that talks about all of your code style conventions in every single Python project you create. So, code style guide, when we talk about code style guide in the Python community, PEP 8 is one of the things that comes to mind. Let's talk about PEP 8. So PEP 8 is the Python code style guide. If you aren't familiar with PEP 8, read PEP 8. If you think you are familiar with PEP 8, go reread PEP 8. And in fact, you should probably make it a habit to reread PEP 8 every 6 months or so, just to make sure that your view of PEP 8 and your own code, that relationship, it changes over time. Make sure you're updating your relationship there. So PEP 8 is the Python code style guide, but it is not your project's code style guide. PEP 8 is not opinionated enough for your project. You need an opinionated code style guide that goes beyond PEP 8. PEP 8 is a foundation for which to build your code style guide up. Okay, do poets wrap their lines using a maximum line length? No, poets don't wrap their lines using a maximum line length. Poets insert line breaks with purpose. In poetry, inserting a line break is an art form. In programming, inserting a line break is an art form. As programmers, we should wrap our lines with great care. And remember that all of your projects should have an explicit code style guide that talks about all of the conventions that you use. Your code style conventions should be documented explicitly. All right, let's switch gears. So if a concept is important, it needs a name. That's kind of a fact of life. We can't talk about things without names. Names give you something to communicate about. Now, unfortunately, naming things is not easy. Naming a thing requires describing a thing, and describing things isn't easy in itself. And once you've described something, you then need to shorten that description into a name. A description isn't good enough to name something. If you can't think of a good short name, use a long and descriptive one instead. You can always take a long and descriptive name today and shorten it tomorrow. It's easier than doing the reverse. So do not worry about the accuracy of, or rather worry about the accuracy of your variable names. Do not worry about the length. The length is not important. The accuracy is much more important. You can always shorten variable names tomorrow. All right, let's take a look at some code with poor variable names. So in this code, I bet you don't know what SC stands for. Anyone want to guess? Source code? So SC here stands for state capitals. You wouldn't have known that without context, though. Do not use two-letter variable names in your code. Use descriptive names. Speaking of descriptive names, what does that I stand for? So is I a two-tuple? Is it something else? What is I sub 0? What's I sub 1? Is I sub 0 state? Is it capital? Is it something else altogether? You could guess, but you might not know. Whenever you find yourself accessing an index, that should be a red flag. If you are accessing an index, you could instead use a variable name. If you use tuple unpacking, that avoids accessing indexes. This is a little easier to guess what's going on. Instead of I sub 0, we have S. Instead of I sub 1, we have C. Avoid using arbitrary indexes. When possible, use tuple unpacking instead. Naming things is good. If you don't name something, it's not important. If something's important, it needs a name. So while you probably could guess what S and C stand for, state and capital, since we already have state capitals there named well, there is no reason not to use real words. There's no harm in this. It makes our code a little longer, but it's more descriptive. Always use descriptive names, even with variables that you don't think you care about. You can always shorten it if it gets too long. Optimize for maximum accuracy and completeness, not for short variable names. Okay, let's look at an example of code that could use some more variable names. This code returns a list of anagrams of word, which is a variable, which are in the list of word candidates. Candidates is a list there. This is not bad code, but it's also not the most descriptive code. In particular, that if statement is a little long. It's a little unwieldy. What if we abstracted out the logic that's inside this if statement here into its own function? So with this is anagram function that presumably we've made somewhere else, our code is now a little more descriptive. We've broken the problem down, and we're now describing the process that we're using and not the details of the process. The process is the important part, not the details. So this is anagram function. Let's take a look at that. This is pretty much exactly what we had before in that if statement. We've simply moved that logic into this function. It could still use some work, though. In particular, word.upper we're using twice here, word1.upper twice, word2.upper twice. So we've avoided some code duplication here by moving those into variables. This is a lot better, in my opinion. I find the conditional expression that we had before a little harder to read than this one that we have now, which is a little shorter. So we could still improve this. One strategy I use when I'm considering whether I could improve my code is to read it aloud and see if it actually sounds like English. So here we are sorting our words and then checking whether the sorted versions of our words are the same, and then making sure that the unsorted versions of our words are not the same. That is not a thing I'd normally describe in English. That's not how I'd describe this problem to someone. That description's not very helpful. So we could write some comments here to describe what we're actually doing. We have two comments here. If we ignore the code and we just talk about the comments, we're talking about words that have the same letters, which are not the same words. That is more descriptive. That's how we'd actually describe this problem in English. So comments are great for describing things, but comments are often a hint that you're missing a variable name or you have a poorly named variable. In this case, we're missing variables. We have an opportunity to make new variables that represent these concepts. So we've turned those two conditional statements that we had before into two variables that describe what we are actually doing. That last line reads pretty much like English. These words have the same letters and they are different words. So we are describing not the process that we are using, but the overall concept. The code is more clear and it's more readable because we're conveying the intent of our algorithm and not just the details of the algorithm. The details are irrelevant for most readers. The intent is important. So we ended up adding 4 extra lines to our code. But we broke down our process a bit. So our code is a little bit more readable at first glance now. Now you may think this is a silly example. It is a little bit of a silly example. In fact, we might revert a couple of these steps and decide we went a little too far. Even if we decide to revert some of this process was still worthwhile. The exercise of refactoring your code reframes the way you think about your own code and can give you insights into your code. Okay, let's take a look at another example. So let's say we're using a complex Django model method. So we've got a method that has a lot of code in it. Now, I don't want you to look at the code. I want you to look at the structure. I want you to unfocus your eyes. Here, let me help you. So we can talk now without you getting distracted over what this code is doing. You see the structure of the code. You're not actually looking at the code. The first thing you'll notice is that there are 3 code blocks here. There's 3 code blocks because there's 3 distinct things that we're doing. This code was broken into sections because each of those sections do something different. If we add comments to these sections, we can actually see what they do. So, in my opinion, adding those comments improved readability greatly. We can understand really quickly what each of those sections is actually doing. And depending on why you're reading this code, you might be able to get away with only reading the comments and skipping over the code itself. Now, comments are often a hint that we have forgotten to name something. We've forgotten to name these blocks of code. Before, we forgot to name conditional statements. You can name blocks of code too. We can do that with functions. So these comments we could turn into function names. These are now separate functions, separate methods in the same Django model. I've left in the comments as documentation strings here because it never hurts to document your code. We've broken these out into separate functions. We need to call these. In our original method, we now only have 3 lines. Those 3 lines describe the process we're using, and they ignore the details. If we wanted to see the details, we could jump into those methods themselves. We have named these actions because they deserve a name. These were important things that we were doing. Therefore, they need a name. All right, let's do a recap. So, read your code aloud to ensure that you're describing the intent of your algorithm and not just the details of your algorithm. And remember that comments are great for describing things, but sometimes when you're adding a comment, it's really a hint that you need a better or a missing variable name. Make sure you give a name to everything, and in general, describe for descriptive and self-documenting code. Okay, let's talk about some of the code constructs that we use every day. There's usually multiple ways to write the same code. Because there are often multiple tools to solve the same problem. So when given the opportunity, I tend to prefer to use special purpose tools to solve special purpose problems. Special purpose tools over general purpose tools. A specific problem calls for a specific solution. So let's take a look at an example of exception handling. So here we're opening a database connection, we're reading from the database, and then we are making sure that we always close the database connection. If you've never seen a finally block before, that db.close gets executed regardless of whether an exception was raised. We always close our database. So whenever you find that you have a cleanup step, whenever you find that you're always trying to do something, or you're handling some kind of extra cleanup case in multiple places in your code, think about using a context manager. It's not that hard to write your own context manager, or rather, it's not that long in terms of code oftentimes. You have to go look up how to do it though. So to make a context manager, we make a dunder enter method and a dunder exit method. Dunder stands for double underscore because there's double underscores around those method names there. Let's take a look at how we would use this context manager. So this is somewhat simpler than our try finally. We're not closing our database connection every time ourselves. That's being done for us. We don't have to worry about that.
Wait, by using the word statement, the
Yes, so that dunder exit that we made is always called automatically for us. That's the context manager's job. It's not our job. So this code is more readable because we've removed unnecessary details, details that to the user reading this code, they usually don't care about. So this closing context manager, actually there is a closing context manager in context-lib, which is in the standard library in Python 3. So whenever you need something like it, you can reach for it. Often you don't need to make your own context manager. You should go look for someone else's. If it doesn't exist, it's not that difficult to write your own. You can look it up, you can get help. Let's talk about for loops. This code loops over something. You can probably tell that even though it's blurred out because I've left in the parts that are important. This code does a little bit more than that though. Specifically, this code loops over something, checks a condition, and adds things to a new list based on that condition. If that condition's true, it takes things from the old list, adds them to the new one. We're using a list append, an if statement, and a for loop here. There's a better way to write this code. So here we're accomplishing the same task, but we are using a list comprehension instead of a for loop, an if statement, and an append. This code isn't shorter. In fact, I think it might be longer than what we had before. But it is more descriptive. It removes unnecessary information that our brains have to process. Not only that, when we look at this code, we don't think looping. Looping is not our first thought. We think turning one list into another list, because that's what that construct is for, this list comprehension. When you have a specific problem, use a specific tool. List comprehensions solve a more specific problem than for loops, which are more general purpose. Let's say we're creating a class that represents items in a shopping cart. So this shopping cart class is a wrapper around a dictionary, basically. Notice that the class, pretty much each of these methods, mostly just proxies to some kind of dictionary method. We're adding something, we're removing something, we're checking to see how many things are in our dictionary. These methods might seem a little bit familiar. All of these methods correspond to operations which work automatically on many native Python objects. When we use custom methods and properties like we were doing, someone trying to use our class has to learn what each of those things do. When we use native operations built into Python, if our class did support those, people who understand Python already will understand what our class is doing. They don't have to relearn everything that we're doing because we're naming things ourselves. So in terms of details, we can make these operators work by using dunder methods like we did in our context manager use case. So with this change, our shopping cart feels a lot more like native Python objects. Someone who's already used to Python, accustomed to how Python works, is going to understand how our shopping cart works. Don't be afraid to reach for operator overloading, to overload these operators with these dunder methods when it's appropriate to do so. By the way, the standard library has some abstract base classes that make this a little bit easier. If you did need to implement these yourselves, you can inherit from one of these classes that gives you a lot of these for free. So if you were ever planning to make your own types of containers, check out the collections module first. It's got your back. All right, let's talk about functions. This code connects to an IMAP server and checks some email. It reads email and does something with it. Notice that one of these functions returns a server object, and the other functions each take a server object. This should be a hint that something weird is going on here. If you ever find yourself repeatedly passing the same data into multiple functions, think of making a class. That is exactly what classes were designed for. Classes bundle up functionality and data together. If you have data and functionality that should be intertwined, a class is an appropriate thing to make. Okay, let's do a recap. When you find yourself wrapping code in a redundant try except or try finally, think of using a context manager if you're doing that same operation lots of times in your code. When making one list from another, think of using a list comprehension. When your objects look like a container and act kind of like a container, think of actually using operator overloading and making it work like a container in Python. And don't be afraid of dunder methods in general. If you have a specific problem, use a specific solution. It's difficult to know what that specific solution is, but as you're learning them, don't be afraid to embrace them. When you're writing code, stop to pause every once in a while and actively consider the readability of your code. You can use this checklist to check to make sure your code is actually readable. Again, I'll tweet the slides afterwards. Remember that every project that you make should have a detailed code style guide. And the more decisions that you can offload to your style guide, the more brain power those who are reading your code will be able to conserve. You shouldn't spend time worrying about how your code is actually structured. You should be able to read your code and understand the gist of what's going on before you dive in. So finally, here's a list of videos that I recommend watching. This talk is largely based on some of these. One of these I recommend first, stop writing classes. I just told you to make classes. That tells you when not to make classes. And that's all I've got.